Hello, this is Ellie Hikima, and I am the captain, aka counselor of Team First. Allow me to give you context to our project. Every year, 8 million tons of plastic are estimated to enter our oceans, which in perspective is about 195 million campers. This means that by the time you've watched this video, 2/3 of a million tons of plastic have made their way to the oceans this month. These plastics currently make up 74% of the diets of sea turtles. We dirtied our oceans, and we need to take full responsibility to clean it. With this, we present to you Operation First, Save Our Seas. Our project combined 2 courses, engineering, a course taken by Kaylee, Kedar, Shreya, and Veer, and conservation ecology, the course I teach. Today, we're tackling the problem of the Great Pacific Garbage Patch, a collection of debris in the North Pacific Ocean, first discovered 25 years ago.
Hi, I'm Veer from Team First, and today I'm going to be showing you my design of a robot which can remove trash from any body of water. So here are the parts. This is a solar panel, 2 solar panels. These are 2 arms. This is an example piece of trash. And this is a motion sensor, this is a motor, and these are 2 jet boosts. So what this motion sensor does is it senses this piece of trash and tells these arms to bring them into this net. And this is the energy source, and when we press a button, this motor, it spins, allowing it to move forward.
Hi, my name is Austin, and this is my design for Save Our Seas. As you can see here, the boat is made up of reusable materials and is made up of arms, a net, a conveyor belt, box, solar panels, motors, and perhaps a water wheel. The net and arms help bring in plastic, which will then be picked up by the conveyor belt and dropped into the box for storage, which can later be recycled or thrown away. The motors help propel the vehicle forward, and this could also be done with the help of like a water wheel, which can use the current of the river or the ocean. Solar panels, wind turbines, or really any reusable energy can be used to fuel these motors, but I feel like in this design, solar panels would be most effective. I hope you have a great day.
So my prototype is basically this box with a net in front of it, so that as it moves forward, the trash in front of it will be collected into the net. There will be a tube behind the net that will allow the water to be released. And after this process is done, there is a lid in front of it so that if you don't want the trash to fall out when you're done, you can close it.
Hello, Kedar from Team First, and I'll be going over my prototype for the Great Pacific Garbage Patch Garbage Cleaning Robot. The Great Pacific Garbage Patch Garbage Cleaning Robot for Operation First, Save Our Seas. Here it is. Essentially what I've done is I've taken an old Beyblade stadium and attached the motor to the back of it. This motor is connected to an infrared receiver that shoots out infrared waves to some sort of controller. And then in the front is the trash collection unit. Basically, trash just accumulates in this kind of box-like thing. And then in the next clip that you'll be seeing, you'll see an actual video of my prototype moving in water. But unfortunately, I wasn't able to include the trash collection unit because it was too heavy.
Is there any way you can control the steering?
Hello, this is Kedar from Team First, and I'll be going over the goals of our project SOS, or Save Our Seas. Goal 1. Our target age of marketing is 8 to 14-year-olds. Kids growing up in this day and age are well versed in the concept of climate change. Not only does this fun project allow kids to further explore their love for building and engineering, but you can also clean the planet with it. Goal 2. Net zero carbon emissions. Our hope is to take our project to the industrial scale. If we're going to be mass producing these, we don't want it to leave a carbon footprint. Our mission is to save the planet. We intend on following through on all these aspects. Then, Goal 3. All plastic used to create this project is recyclable. This way, we don't create excess waste to build something that's supposed to clean up waste. Goal 4. There are 4 variations of this kit. these potential sources of energy that can replace the batteries that we're currently using. We can use solar cells, as Veer was talking about, or go hydroelectric. We can also use organic solar cells, which are made of carbon-based materials, or go with the cheapest alternative, rechargeable batteries. Okay, so here's our ideal design for our garbage cleaning up robot. So if you look at the top view, these two rectangles are going to be very high torque, high speed motors. This way our motors will be able to propel the boat at an appropriate speed, as well as be able to push the whole weight of the boat. Then if you look over here, this is going to be our kind of trash collecting conveyor belt. So basically trash is going to be hooked onto these little hooks on the conveyor belt, and then they don't have to be hooks, they can be platforms as well, and then those are going to be dumped into the trash collecting bin. And then this is just a side look of the whole model, and then we have the power supply.
Hello, my name is Eugene, and I will be presenting my prototype, which is prototype 0.3. Over here at the bottom, there will be two floaties that stretch 0.3 meters into the water, and those will lead to this to scoopers over here, which lead up here, and then it drops down into a trash can over here. This design is run by two motors, and it has two axles, one over here and one over here. In between will be a stretching material like this band. To show you how this works, I brought a few Legos that I will put onto this conveyor belt. I will activate the switch and it's off. Thank you.
So that was our video on the process of creating an innovation that we hope would shed light onto our seas that deserve more acknowledgement. Thanks for listening. Operation First, signing out.